Hello, my name is Sarah Evans, and I will be presenting on the Nipah virus. Here's a brief outline of what I'll be going over in this presentation. First, we'll start with the infectious agent. Then we'll go into outbreaks, especially the notable ones. Then we'll go into what I find most interesting, which is the transmission of the disease, followed by signs and symptoms, as well as the long-term effects, leading into the problem, which is why you really should care about this disease. Then I will tell you about the most recent outbreak, and then we'll go into what the future holds for this disease. So the infectious agent of the Nipah virus is the Nipah henipavirus. It's a negative single-strand RNA enveloped in these various proteins, including nucleoproteins, matrix proteins, and glycoproteins, which are important for vaccine research. The Nipah henipavirus is similar to both the Hendra virus and Cedar virus. What's notable about the Hendra virus is that there is a vaccine for horses, which are particularly susceptible to this virus. And with the Cedar virus, all the animals that are usually susceptible to Nipah and Hendra have antibodies against the Cedar virus and rarely, if ever, have any adverse effects. So as promised, some notable outbreaks. The first outbreak was right before the year 2000 in Malaysia. It was originally thought to be Japanese encephalitis, and it had a 40% mortality rate. So as you can see by the statistic, it's a lot of people that died compared to how many were infected. The second outbreak occurred a few years later in a completely different geographical area, and that was in Bangladesh and a city in India. What was particularly concerning about this disease, this outbreak, was that the mortality rate was so much higher. And this is mostly in part to the respiratory symptoms that were included along with the typical Nipah virus symptoms. The most recent outbreak we'll go into later, which was in 2018 in Kerala, India. So transmission. This is what I found really interesting. So bats are the second most prosperous mammal on the planet, and they carry over 200 viruses, many of which are pathogenic to humans, and the Nipah virus is included in that. So they are the natural host of the Nipah virus, and the Nipah virus also has multiple zoonotic reservoirs, which is how a lot of times the disease has been passed to humans. These reservoirs include horses, dogs, cats, most notably pigs. The route of transmission, both for these animals and for humans, is direct contact through mucosal membranes. What's concerning about this virus is that it can live outside of a living host for about 3 hours in fruit juices and over 18 hours in bat urine. So in this graphic here, you can see the way that the virus spread for 3 different outbreaks. This blue one over here shows the first outbreak in Malaysia. The virus started in bats, as per usual, and they ate fruit from a tree. The fruit fell, and pigs ate it. Problem is, the fruit here had the saliva from the bats, which contained the virus. The pigs were infected with the disease, and humans contracted it from them as they were farming them. What was particularly devastating about this outbreak is 1 million pigs were killed in an attempt to stop the spread of the disease. Over here in red, you can see how the transmission for the second outbreak occurred. It started with bats, and then in Bangladesh and India, they have a common practice of drinking palm sap juice or palm sap liquor. How they do that is they cut a notch in a tree, put a pot underneath, and collect the sap. This takes many days, and during this time, bats often will come and feed from these pots, leaving their saliva, urine, and even fecal matter. All of this contaminates the palm sap and is ingested later by humans, who are then infected. In the middle, we have this green outbreak, which is from a more recent outbreak in the Philippines. They're not really sure how bats were able to infect horses with the disease, but the horses got the disease and people got the disease from horses, either through eating their partially cooked meat or in slaughtering these infected horses. Signs and symptoms. So the incubation period is 5 to 14 days from exposure. And once you start displaying symptoms, you'll have a fever and a headache that lasts anywhere from 3 to 14 days. Accompanied with that is drowsiness and disorientation, which progresses into mental confusion. There have been reports of extreme giddiness, which is very weird whenever someone is in all of this distress. Within 24 to 48 hours of these first symptoms, it can progress to a coma, which later leads to death. In some cases, respiratory symptoms have been very notable, and in most of these cases, along with the neurological symptoms, there are pulmonary effects. How this is diagnosed is based off of the clinical history once you've been admitted into the hospital, so how your symptoms are progressing. They also use real-time PCR, and then a test for the antibodies within your system, as well as isolating the virus in cell cultures. So if these symptoms weren't bad enough, 40 to 70% mortality rate. It's a huge deal. And local news sources have reported even greater mortality rates, upwards of 89%. If someone does survive this disease, there are many long-term effects that are pretty common. 20% are left with seizure or convulsion disorders, and many report personality changes. Additionally, there is often delayed onset encephalitis because of this latent infection that appears months or years later. So you may think, okay, I've survived it, this is great, I've beaten the odds, only to find out years later the virus reactivates and you cannot survive. So all of this is really bad, but the big problem is there's no vaccine and treatment is limited to supportive care. Not much you can do. But there is optimistic data out there. With the most recent outbreak, it was devastating in the first 15 days. 17 of the 18 people infected died. This is an 89% death rate. However, after these, the Indian government worked together and there was a lot of strong leadership that was able to successfully control the outbreak. Over here are just a few of the logos of different agencies that came together and worked together. And it wasn't just limited to the Indian government. The Indian government reached out to Australian governments for potential vaccines, as well as to Malaysia for additional vaccine research materials. But what we really got out of this outbreak is there's a need for seasonal preparation. A lot of the cases could have been stopped if people were more informed about it, if there was more PPE in the hospitals, which we're all familiar with the current pandemic, as well as additional electronic health reporting and data collection, which just helps streamline the process of finding these diseases. So, future outlook. This disease is very relevant. It is on the World Health Organization's priority list because there is no vaccine and there's no treatment. So we're really limited to preventative care. So that means a lot of surveillance and awareness of the disease, making sure that farmers, especially people and other people that work closely with animals, are aware of the disease and can see that in their animals, and stay away from them because of that will prevent the spread. Also, research into the ecology of bats is underway, trying to see how the mating seasons of bats correlates with the seasonality of Nipah virus. Additionally, vaccine research has been underway for many years now. Some common drugs have been effective in vitro, as well as have shown strong potential in hamster models. Going back to one of the first slides when I asked you to remember the glycoprotein that's around the envelope of the genetic material, this antibody is the IgG that we've talked about in class. And it has been successful in ferret and African monkey models because it has attached to those glycoproteins and made it harder for the virus to infect cells. All this considered, this disease is really important. Research into it is very necessary because there's not much we can do. And that's Nipah virus in a nutshell. I look forward to any questions you guys may have. Thank you.